Every single second, the massive nuclear furnace at the center of our solar system blasts the Earth with enough energy to power our entire civilization for a year in just 1 hour. Yet for 2,000 years, humanity stood under this torrential downpour of power, completely unable to catch a single drop. Even as recently as 1948, when the brightest minds at Bell Labs finally cracked the code to the first silicon solar cell, the results were laughable. It had an efficiency of just 6%, a massive expensive slab of glass that could barely power a child's plastic toy. Back then, oil giants didn't see a threat, they saw a joke. But today, that joke is dead. We have achieved a cost reduction so massive it defies logic, a 286,000% drop in price. We are finally standing on the edge of a world where energy is essentially free. But as we are about to discover, free comes with a dark, heavy, and metallic price that no one is talking about. We are currently living through the most significant energy transition in human history, shifting from a world of extraction to a world of reception. But why did it take 2 millennia to get here? And why, despite having the cheapest energy in history, is the global power grid still on the verge of collapse? In this deep dive, we are going to expose the 3 engineering secrets that changed everything. First, we will break down the 6% paradox, how we turned a ridiculed toy into a global titan through a technology called N-type TOPCon. Second, we will confront the 80 petawatt equation, revealing why our biggest problem isn't generating energy, but the desperate multi-billion-dollar struggle to store it. And finally, we will expose the dark price of cleanliness, the hidden dirty irony of the silver and silicon mines that make the green dream possible. Chapter 1. The 6% Paradox and the Engineering Resurrection. To understand where we are going, we have to look at the embarrassing state of where we began. In 1948, the world was obsessed with the birth of the transistor, but in a quiet corner of Bell Labs, another revolution was struggling to breathe. Scientists had just created the first silicon photovoltaic cell. It was a miracle of physics, but a disaster of engineering. With a meager 6% efficiency, it was a colossal waste of resources. To put that in perspective, a solar panel the size of your front door back then could barely generate enough current to flicker a single small light bulb. But the real barrier wasn't just the physics, it was the price tag. The production cost was a staggering $286 per watt. In $1948, that made solar energy thousands of times more expensive than coal or oil. The petroleum industry looked at these solar toys and laughed. They believed solar would forever remain a niche curiosity for satellites and space explorers. However, engineering is the art of relentless refinement. For 70 years, the industry fought a war of centimeters and percentages. We moved from standard monocrystalline structures to the current king of the hill, N-type TOPCon. This isn't just a fancy name, it's the technology that finally broke the curse. By adding an ultra-thin tunnel oxide layer, engineers stopped the recombination of electrons, allowing the cell to breathe. Today, we have achieved efficiencies exceeding 25%. But look at the math. While efficiency quadrupled, the cost plummeted to less than $0.10 per watt. That is a cost reduction of 286,000%. We didn't just make solar better, we made it the cheapest form of electricity in the history of the human race. We have successfully resurrected a toy into a global economic weapon. But as the energy begins to flood the market, we are facing a physical reality that no amount of efficiency can fix. If energy is now this cheap and this efficient, why isn't every single house on Earth disconnected from the grid? The answer lies in a number so large, it's almost impossible to contain. The 80 petawatt equation and the storage war. Every second, the sun provides the Earth with 80 petawatts of energy. To give you a mental image, that is 80 million billion watts. The sheer scale of this energy goldmine is staggering. As we mentioned, the amount of solar energy hitting our planet in just 1 hour could meet humanity's total energy needs for an entire year. So if the energy is there and it's now cheaper than coal, what is the holdup? The problem has never been the quantity of energy. It's the intensity and timing of its reception. We are receiving a massive fire hose of power, but we are trying to catch it with a thimble. We live atop an energy gold mine, but we don't have the bags to carry the gold away. This is the energy storage challenge, and it is the single greatest bottleneck in human history. Traditional lithium-ion batteries are excellent for your phone, but they are a catastrophic choice for a global power grid. They are expensive, they degrade, and they simply cannot scale to hold the 80 petawatt fire hose. However, a massive breakthrough is emerging from the laboratories of China and Sweden that might finally end this storage war. Liquid solar fuel. Imagine a specially designed chemical liquid that, when exposed to sunlight, captures the energy and stores it in its chemical bonds. This isn't just a battery, it's a stable fuel. This liquid can be stored at room temperature, transported in standard tankers, and, most importantly, it can retain that energy for up to 18 years. But as we rush toward this liquid future, we are ignoring the scars we are leaving on the earth to get there. We call it green energy. But if you saw the mines required to build these panels, you might call it something else entirely. The dark price of cleanliness. There is a massive irony at the heart of the solar revolution that the marketing brochures never mention. To make solar energy the cheapest in history, we had to build an industrial infrastructure of unprecedented scale. Specifically, we have become addicted to two materials, silicon and silver. The solar panel industry currently consumes between 10% and 15% of the world's total silver production. Every time you see a gleaming solar farm, you are looking at thousands of tons of precious metal stripped from the earth. The green dream is built on the back of massive heavy-duty mining operations. Here is the dirty secret. We use colossal diesel-powered carbon-spewing machinery to extract the minerals needed to produce clean energy. The transition to solar isn't a free environmental pass. It is a trade-off. We are swapping carbon emissions in the air for heavy metal mining in the ground. To purify silicon to the level required for a TOPCon cell, you need extreme heat, which is often provided by, you guessed it, coal-fired power plants in industrial hubs. We are front-loading the carbon cost of a solar panel's 30-year life into its first few months of production. As engineers, we have to ask, at what point does the green outweigh the gray? As we continue to scale, the demand for silver is projected to outstrip supply, potentially driving the cost of solar backup for the first time in decades. We are in a race against material exhaustion, and the only way out is a total shift in how we define a solar cell. This brings us to the ultimate revelation, a discovery that doesn't just change how we get energy, but who controls the very fabric of our civilization. The ultimate revelation is this: we are no longer in an era of energy scarcity. We are in an era of materials sovereignty. The war for oil is over, and the war for the periodic table has begun. The 0.76 angstrom ionic radius of lithium and the crystalline lattice of silver are the new atomic borders of the 21st century. The same element that once powered a 6% efficient toy is now the most powerful geopolitical tool on the planet. Whoever owns the refining process of silicon and the storage capacity of liquid solar fuel doesn't just own a utility company, they own the keys to the future. We are transitioning from a world where we burn the past to a world where we harvest the future. The secret is no longer in the ground. It's in the engineering of the atom. The journey from a 6% energy-efficient toy to a global energy giant has taken 2,000 years of curiosity and 70 years of precision engineering. We have the data, we have the sun, and finally we have the technology to store it for decades. The solar revolution is no longer a possibility. It's a reality. But to stay ahead of this transformation, you need to understand the technological forces at play before they change the economy as we know it. We're building a community of thinkers and engineers who want to explore the intricacies of the global energy war. If you want to master engineering the world and stay informed about the latest developments in the chip war and the future of energy, you need to be part of this. Subscribe now and join us on this journey. The world is changing. Don't just watch.